Hello everyone, and welcome to Jumperman Tech, where we specialize in HVAC. We do everything DIY, and today we have a service call for an ice air PTAC unit. Thank you to everyone tuning to Jumperman Tech. We have two ice air PTAC units. These actually come with these Habitat thermostats, and here we have a wireless receiver. So we have a wireless thermostat. At the moment we have the power light blinking. We got to start with pairing this thing. That sounds like fun, but they're having an issue here where it's tripping the breaker intermittently, and apparently, funny enough, we're in the Omega building, but the building across the street is having such a bad issue that they brought the units over to us and handed us the torch to see if we can help them out. So at the moment, connected here, this unit's run on 120. I have a little breaker set up right here. This is a 20 amp breaker on here. So it's a regular air cooled air conditioner for cooling, and then on this side they use hot water for heat. So in the enclosure is most likely a hot water coil above the unit. Over here, this is the evaporator fan motor, blows air across that coil and they get heat. All right, we downloaded the manual they gave us these units. I guess we're starting from scratch here. Okay, device pairing. Hold down fan mode and down button for more than 3 seconds to initiate the pairing process, and set the 10-minute countdown timer in action. This will allow pairing to 8 base modules. Let's see. You would press and hold the pair button. So we got to press those 3 buttons here while we press the pair button on here, which is that little red button. But I already pressed that. That's why it's blinking. When I didn't press it, it was a steady light. So let's go ahead, do what you got to do here. Fan mode and down. There we go. So it says pair. Some numbers are going through. And I guess that's something, the 10-minute countdown. So let's give this some time and let's get this thing paired up. All right, looks like we got this thing paired. Basically, you would hold this pair button down for 5 seconds when it's flashing green. Then you hold down mode and fan, and this thing goes into the pairing cycle. Once the light turns steady green, it pairs. I just put the system on fan on high. It's gonna be low. Change the speed, nothing trip. High, low, and auto here. Okay, no problem. Here's our evaporator fan motor. Some switches, control board, capacitors, relays. Got a freestat in this thing. We got the meter right now across the common wire for the compressor. So they're talking about this thing tripping the breaker, so we're gonna cycle cooling on and off, on and off, on and off, till at least we see something. Maybe we see like a volt amperage spike. We have locked rotor or something. Maybe it's happening intermittently. So we're just gonna keep an eye on this. Let's put it on. You can let it hang. You're good. Yeah. So we're just gonna watch this, and we're gonna watch amps to see what happens here. This is not a complicated unit, but they're having a real crazy problem. They said they had to switch out 300 of these units last year in this building. Apparently they have over 1,000 of them, and they just keep having problems. This switch right here, they're normally open and common. This thing right here, that is our compressor relay. So if we jump out those 2 terminals, which is right here, 2 wires, the black and the blue. I'm gonna turn this thing on and off, on and off. I'll let it start naturally. Let's see what happens the first time. After that, I'm gonna let this thing run and keep going. So if something, maybe they're locking up at some point, one thing we would want to do is check the capacitor, make sure the rating is good. That is a silver casing around the capacitor. That's a run capacitor. But with the permanent split motor, this actually helps it start too. So if you have a low rating, you're gonna have a problem. If it has trouble starting, there's a good chance it can lock up, pull high amperage, and blow your breaker. So let's see what we can do. Okay, it started, pulled about 4 amps at first, and now we're pulling about 7. Condenser fan motor, compressor might have started first. Here's your compressor. And I can hear the condenser fan motor running. No problem. We're gonna have to keep cycling this. We're gonna have to keep cycling this because we're trying to catch it while it trips. Got the wiring diagram here. While we got this going. Yeah, this sounds like fun. I just turned the power off. Before we start, cycling this compressor on and off with the condenser fan motor, right? We need to make sure that capacitor is good right there with the silver casing. That's a run capacitor. But in this setup, even though it's a run capacitor, this actually helps it start too. So if you got a low rating, eventually you're probably gonna lock up, and that would cause an amperage spike and trip your breaker. So let's isolate that capacitor, discharge it, see what it's rated for, and test it and see if it's within spec. Here's your capacitor. It's already discharged. The numbers are on the bottom. This is a 55 microfarad capacitor. Man, that's a big boy for this thing, man. 55 MFD. Yeah. So take a picture of the wiring. You want to isolate it. Typically what I see is if you just take out one side of it, you can test it. But if you want to be 100% sure without any worry, just take off all the wires, isolate it, discharge it, and test it. We have our meter set to capacitance. We got 1 lead on each side. It's rated for 55. We have 54.5 microfarads. There's no problem here. We also want to make sure there's no loose connections. Loose connections increase the amperage. That could be a problem as well. Small things like that cause big problems. These are all tight. Let's put this back in its casing. Then before we start running those tests, here's the compressor. Let's take a look at the wiring. Let's make sure nothing is pitted, burnt, corroded, loose, any of those things. We're gonna do a visual inspection there. Make sure all those things are intact. If it is, we're gonna begin our tests. There's just a couple little things you can do before you start doing all these things, but clearly this machine starts. You mentioned this thing could run for hours, days, and just breaker trips. So it's gonna be a tricky one. So, you just gotta keep cycling it and act like it's been cooling for days. So let's say we might do this 20 times. All right, well that might be how many times we'll start on and off within maybe a couple days or a day or two. It depends however these people are using it. But just got word it's 1,200 apartments there. It's not 1,200 units, so they got way more than that. And this is beginning to be a super costly problem for them. Let's see what we can do. All right, we open the top. Condenser fan motor, condenser coil, compressor. Let's open up here. Let's see if we see anything. Let's do a visual inspection before we begin. Terminals are clean, none of them burnt. Everything's tight, everything's insulated. Capacitor's good. System starts on its own. Now is when the tricky part begins. All right, we got the boys testing this one. Pulling about the same amps. Capacitor is good, terminals look good, system starts on its own, doesn't trip. Yep. Looks like it's a good time to bring out the Megameter, run one more test on that compressor, and then we're just going to keep cycling this thing on and off till we see something, because this sounds like it's going to be a tricky one. If both machines run, you already know these compressors are not grounded, and you have continuity between all your windings, so we don't need to run that test. It's already obvious. Using the Megameter would be a good test. I'll show you guys a picture of this wiring diagram, but CP I'm seeing now is your run capacitor for your compressor. It's gonna be this guy that we just checked. If you look here, these two black devices here, these are actually also capacitors. This one right here with the brown and orange, this is another capacitor labeled as CP2 for your evaporator fan motor. And then we have another one for your condenser fan motor. And that's gonna be this one back here. So we should check those as well. I got my 2 leads across that rear capacitor. It's rated for 10, and you have exactly 10 microfarads. Condenser fan motor capacitor is good too. Perfect rating. Next we have this capacitor here, rated for 3.5 microfarads. Goes through these wires, but it goes directly into the evaporator fan motor. So I see they made a connection here. There's a connection in between here. The sleeve over it. This would have to be cut to even get a test on it. We got 10 microfarads on this other unit as well. All right, man, put the wires back. Everything's checking out the same. Cut the 2 wires, got 1 lead on here, just wrapped it around. Now let's hold this on here. 3.5 microfarads. Perfect reading on all the capacitors. So all capacitors check out here. We just check the evaporator fan motor capacitor. We got 3.3, 3.4 microfarads, rated for 3.5. That's fine. All capacitors are good and everything checks out so far. Here on we use the Megameter test on this one too. I have a feeling we're not going to see anything because these units are pretty new. Got the Megameter out. So we're going to go from each terminal to ground. You want the casing of the motor, but there's paint on it. If you want a really good reading, also you might want to sand down the pipe. So we're going to check each terminal to ground. And we're going to apply 500 volts to it. Let's test it out. Holding up good. Maxed it out. Let's wait for the voltage to drop on the bottom. You see, bottom right, 0 volts. And then we're going to take this and go to the next terminal. Come on. Okay. Test. Climbing up. Alright, maxed it out. The voltage dropped 0 there, so we're safe. And now the last one. Test it out. Started off a little low for a second, but you see it's climbing. The winding insulation is good. Absolutely nothing wrong here that we see. Alright, I'm getting creative here. So look, I took off the 2 wires for the relay there. Common and normally open right here. So I put alligator leads there. Because I don't want to be putting my hand in there, you know, putting that there. That's gonna be it's gonna pull a lot of amps. 2 leads here, 2 leads here. I'm gonna tape it up. Try to put this in a safe spot. I'm gonna like this. I'm gonna cycle the compressor on and off. It's not waiting for the delay, and like this, I can keep the evaporator fan motor running each time. Let's see what this does. This should energize both the compressor and the condenser fan motor. First things first, don't try this at home. So I used a screw that went here, mounted this switch, so I don't have to deal with the electrical there. Tape that off, and I tape this off. So I'm gonna manually control the compressor, ready to run some tests. You could also check the other motors with the Megameter, but I really have a feeling it's a compressor because they did mention at some point that tries, you hear a loud humming sound and the compressor, and then the breaker trips. That sounds like locked rotor on the compressor to me. So this might be happening intermittently, so we're gonna try to simulate that with basically cycling, you know, the compressor on and off multiple times. Okay, when I set that up, unit wouldn't turn on. That might be sending power to the board line, that common. There is another way of doing this too. Okay, so that common wire looks like that just because it goes on the compressor relay, it actually feeds the entire board. So we had no 24 volts energized the transformer. This is the transformer. It's actually built into the board. Anyways, if you look closely, I have my jumper cables across the 2 terminals. Okay. Switch is off. So then we can run this in fan, and we're not gonna put it in cooling. We're gonna control the cooling with that switch. So I got the system only on fan. You can see the fan is running. Got my jumper across there, right? So this switch is gonna turn on the compressor and the condenser fan mode. I'm looking for an amperage spike. Come on, show me something. When I click it, it should turn on. 8. It drops down and ramps up. You know, this crazy setup. Don't try this at home. Let it breathe for a second. Right there, 38 amps. Come on. Oh, whoa, there we go. Lock rotor, baby. All right, so the other unit checks out with the Megameter as well. Could very so be having a similar issue. And when I did that other test, we energized the compressor and the condenser fan motor. What we could try to do as well is isolate this and see if it's the compressor or the condenser fan motor, but considering what that compressor or something might draw, it's got to be that compressor. Let me see, sometimes it might tell you lock rotor. Cooling 9.8 amps, heating 0.65 amps. Doesn't show. Disconnected power wire for the condenser fan motor. We could run that same test again just to isolate that motor so we know it's 100% just the compressor, but it's got to be that compressor. Yeah, I don't think the other little motor, tiny little motor, is going to pull that much amps. Evaporator fan motor running. Condenser fan motor wire disconnected, isolated. We're only going to energize that compressor. We got the amp meter across the common on the compressor. Better do this quick before this thing blows up in my face. That spark we saw earlier, yeah, basically my wire broke. No continuity. So to do this one last test, we need a jumper cable. And it looks like we're gonna be going through these like like dealing with a short and blowing out fuses, but let's see. You could actually see some kind of got darkened up a bit. A little hard to see, but it is what it is. I stripped the wire back and crimped it back on. Let's try this again. All right, let's try this again. 39 amps. This thing's gonna explode. Turn that off before it does. Ooh, this thing is smoking. And that is why you have breakers, because you're gonna start melting wires and all those things. That was the closest thing to the circuit, so that's gonna go first, but thank God for whoever invented breakers. Man, you could smell this problem. So that was only the compressor in line here before we energized the compressor and the condenser fan motor. This time only the compressor. So my final diagnosis, faulty compressor. Rest in peace, my friend. By the way, there's nothing connected to the condenser fan motor at all. It's completely isolated. Look, now it starts normally. Okay. Now it's lock rotor. Turning that off before we start smoking. And there you go, you see? This is an intermittent problem. That just goes to show you. It starts, and then it doesn't. And there's no wire connected. Turn off the power, guys. Unplug that for a second. Condenser fan motor wire. Condenser fan motor wire. This is your whole condenser fan motor. Basically, we took it out of play. So the only thing we're testing here, and the only thing you're reading here, is that compressor and you have a locked rotor problem here, and that's the end of the story. As far as this one, we're gonna have meter on the common and the compressor wire, and we're gonna let this run naturally. Just gonna work the thermostat on and off and act like the machine's being satisfied on temperature, and just see it happen naturally as well. But it's gonna be a wrap for the other one. Intermittent lock rotor issue. There you go. 40 amps. Still freaking running. Oh, and it came off lock rotor. That stood on lock rotor for way too long though, but this thing must be having the same problem here. Here we go again. I'm surprised this thing's not tripping yet. I hear the condenser fan motor started. You can hear it running. That's the compressor drawing that. That's staying locked for way too long. How long that's staying locked? Come on. Why is nothing melting yet? Smack the compressor, you might free it up. Honestly, there you go. It's staying on lock rotor for too long. This is a heavy duty cord right here. As far as none of that trip, to be honest with you. That stayed locked for way too long. When the machine starts, it does pull a super high amperage, but that's like a split second. Some meters don't even catch that. This thing was sitting on here with that amperage, so there you go. I'm good off this. If anyone found this video interesting or helpful, please drop a like, comment, subscribe as I come out with new videos every week, and I'll catch you all next time.